Hello and welcome to another video. In this one, we're going to be talking about conditional context managers, which I actually talked about in another video, which I'll link in the description. That one was using exit stack, which actually I think is a better solution to this, but I also wanted to show you null context, and let's jump into that. Okay, so null context is a context manager that's part of the context lib module, part of the Python standard library. And it was added in Python 3.7, which allows you to do conditional context managers. There's a pretty basic example here. I'll go over some of that below as well, and show you one use in pytest that I find interesting, but I tend to not do myself. And just another note, in 3.10, it also received asynchronous context manager support. Now, I still prefer the exit stack solution in actual code, so I'll link that video in the description, but today we're talking about null context. Okay, one case that comes up a lot in the pytest issue tracker, so much so that we've documented it, is to conditionally test a function that may or may not raise an exception. Now, in my opinion, you should actually have two separate tests, one that tests the exceptional behavior and one that tests the normal behavior, but sometimes people like to over-engineer parameterize to cover both of those cases at the same time. And so I'm going to show you how to do that, even though I don't agree with it. All right, so to get started, we're going to set up a virtual environment. Pip install pytest, and we are going to make a little simple test here. Let's just say that we are going to, I don't know, square a value. Let's do, I don't know, square rooting a value. That way we can give it a negative value and get an exception out of it. Sure, that sounds reasonable. Actually, does it raise an exception in Python, or does it give us a complex? Okay, good. Value error. Perfect. Great. That's what I wanted. Float to float, and I don't know. This is not a very interesting example, but you can imagine a much more interesting one. Math.squirt of x. Cool. And we also want to test this at the same time. And if we do pytest.mark.parameterize, let's say, let's actually do a test, test f errors, and context manager here. Sure. This is how we can do it conditionally. And of course I won't parenthesize it because parenthesizing a string does nothing. Oh, we need the input as well. Input val and context manager. So we do need to parenthesize this. Input val context manager. Okay, so for -4, -5, we should get a pytest.raises value error. Something like this. And with cm f of input val. Just a simple test like that. Pytest t.py. And we have a passing test for our particular value of -5 and should raise a value error. Now, you might also say that a value of 1 should not raise a value. And there is no pytest.did.not_raise. Mostly because it's a little bit silly to do this. Like your test, I have maintained several other testing frameworks that added something similar to this, and it just ended up being something that people slapped on every function without thinking about it. But of course, you don't need to do that because any error in a test is already going to trigger a failure. And so of course, there's no did not raise. But you can use the context lib module as an example of that. Context lib, you can use null context, context lib.null context, and that is our did not raise. Now you might also want to be a little bit more explicit and say did not raise equals context lib.null context, or from context lib import null context as did not raise. That way you have a nice name for it, but again, I don't recommend any of this at all. I'm just showing you as an example. So now we can say, if we are passing in 1 here, we don't expect it to raise a value, and so we can use that as a context manager here. Now this is kind of abstracting away the conditional part. In actual code, you might have something like, let's call it G, that way it's not the same. If some condition, you would have your context manager equaling to context lib.null context. And in the other case, let's say, we open a file of null. And then down here you can do with CM, do whatever work you need. So this is how you would use it conditionally. Now again, I would still use exit stack here because there is a situation where the program is interrupted between this line and this line where this file descriptor gets leaked. And so if you did that with exit stack instead, with contextlib.exit stack, if not cons cm equals, well, actually, just say as f or something like that. F equals, and this is the other video, so I'm just rehashing the other video very quickly. Enter context, open dev null. So this would, give you a little bit more confidence that you're not potentially leaking this file descriptor. Now, of course, there is still a situation in this where, this function returns before the enter context runs, and yeah, there is still a little chance of leak here, but that's the same even with the with statement, so not really losing anything there. But yeah, this is null context, and one kind of anti-use case, as well as one kind of, I've done this case before, so I think this is a perfectly reasonable use for this. Anyway, hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.